This is Packet 6, Class 13, May, the first Monday in May. I'd rather have a Monday in May than a Friday in February. That's always been what I've said. I'm giving away lots of books. I need to put some books out on the front porch for you guys in case you want to look through them. But I got about a dozen books in my classroom that I'm trying to get kids to pick up. And they're good books. I mean, I don't keep crap books. They're good. I just don't have room for them. And with retiring and all, I just soon you all have them than me put them in a, a garage sale or something. Last week, we did this test. Now, as far as I can tell, most of you took it. If you didn't, if you're here, you're probably a kid that would normally take it. But I think there are a couple that didn't. And I emailed them to everybody that I could think of that's virtual. I double checked my list. I emailed them to you Friday. So you should have had them. And so most people have turned them in. I'll start grading those tomorrow night. Tonight I'm grading the practice problems to get those points on there. Anyway, if that somehow slipped your mind, you need to take that ASAP, turn it in. You'll lose some points for being late, but it's better than getting a 0 out of 150. This week, oh, look at that. Is this thing on? Take a look. Okay, here it is. It's May, the lovely month of May. It's here, the lusty time of year. Does anybody know what musical that's from? Ayo, thank you, Ayo. That is from my favorite musical that I saw when I was 10, 1969, Camelot, 68, somewhere in there. And that was Guinevere. She sang that. And she burned at the stake a few days later, or almost burned at the stake. All right. Anyway, May is a very good month, very busy, a lot of pressure, but the end is near. We're down to, well, let's take a look. First off, what's happening this week? At some point, I've got to give everybody a sex talk. It's actually HIV, AIDS / sex / STDs. And I'm thinking, what? Now we're doing it after the prom? Anyway, so I don't know if it'll be the 5th. It'll be a day. And it turns out I marked all these out because I think all of my AP exam schedule was based off something I saw in January or December, and apparently it's changed. So I'm going to go back and recalibrate and put on the new schedule for the AP test. And there's the day that the AP English, the junior version of AP English is given, that's the day I'll have most of my kids gone. Only 5 or 6, but then that will probably be the day I do the AIDS HIV thing that I'm required to do by state law. So, and I'll probably then do it here too. So we have it. May not record that one. I don't know. But anyway, that's coming. Probably not the 5th. It probably isn't the 5th. I doubt it. It'll be somewhere the next week or the week after even. Our final flashback, the kids have agreed to do flashback virtually on Zoom. The actual flash off will now be on Thursday, the 13th, not this time, but because they need to be able to play too. So it'll be in the evening if you can make it. It'll be about a 45-minute process at the most, 45 minutes. And the winner, if it's you all, I'll do something for you. For them, they're like either get the next day, the 14th, they're going to get, if they can beat you. You got some pretty good ones, you all. You have a good shot at it. But if they can beat you, one of their classes, they're going to get like donuts and bagels and orange juice and, just my treat. On the 14th, if it's third out, it'll be pizza. For you all, I don't know. We'll think of something. We'll have a little party. Okay. We'll have a picnic or something if you beat them. Okay. So that's next week. Next week, then we'll do Blue Day for test 6A on the 12th. And that'll be the day that I go over the test with you and be like a video key. And those are always real popular. And then you'll turn it in, you'll submit it back in by midnight the 14th. Okay. And then thus begins the next, and the year is almost over when you're getting the PDF, the take-home test for 6B. And that'll be available the evening of the 16th. I'll hand it out in 2 weeks. And that is the day that taxes are due, which is a killer for me because I do my own taxes, and I'm not going to be in a good mood. I promise you that for a few days there because I'm going to owe a lot, I think. And so that starts all that. This is long-term stuff. We're going to, on the 21st, we're going to have a play day on the West Lawn, and we'd love to have you come because you're part of the class too. And we're going to have a picnic, a little cookout, bring some food. We're going to take our class picture, everybody together, and then I'll separate them into classes. While you and all these other virtual kids take your picture, be outside. You can wear a mask, whatever. And then we're going to, this will be at lunch. Sometime it'll be that day. And we'll do a spring dance out there where everybody takes, everybody gets together in spring dance. We'll take a class picture. We'll do a huge tug of war. I have a meter now that measures force, and we'll do a big tug of war with that meter in the middle. And then other things like that. That's coming up on the 21st. It'll be a nice day. And then we have finals week. For most of you, a lot of you, your year will end. Well, you being virtual, you'll get your test on the 26th, available on the 26th for the Packet 6B test. And you'll have till really the 28th. You'll have to the 28th to get it in. More about that later, but these are long-term, looking way down the road. So as far as the number of these Zooms we have left, not counting today, we have 4, 9, probably won't have on the 21st, 13, 14. 14 more. And then the 25th, you won't have one. Yeah, so 14 more of these. Makes me happy, makes me sad. This was at the prom. Emma took that picture, took that selfie. And I've been doing prom since 1986. And I'm always the graveyard shift. I'm the cleanup guy. I'm the guy that comes in about 10 p.m. and works till midnight, hanging out at the student union at OU. That's where it normally is. Well, so I show up at 8 o'clock. I'm kind of clueless as to what's going on. I'm only there a half day. So I show up at 8 o'clock thinking I'll do the 8 to 12. I'll help everybody out, right? Well, turns out that it's over at 9. It was a good prom for I think they did a great job. And if you guys went, I wish I'd seen you. But I did see a few people that were still hanging out or came late. So anyway, so everybody's been working on this thing for like a week and busting their butt and making all this stuff. And so I show up in the last hour. Well, then on Sunday, they were all this on the group me. They were giving all these congratulations and mentioning my name. Thank you for David Askey for coming to, and I'm going, what? So I made this meme that the prom committee is thanking me for all my help. And I basically showed up the last hour. I take all the credit. I hate people who do that, but I didn't mean to do that. There's been some controversy this weekend on the temporary cushion You know, it's always like 99 out of 99, or it's got up to a high as 140 out of 140, something like that. But now then it's dropped all the way down now to 22 out of 22, but I made it 22 and then I forgot to go back and change the total to 22. So for a while there, it was 22 out of 44. That people, trust me, people have checked on that, and well, I fixed it. So it's 22 out of 22 now. As of tomorrow night, that's going to go away. It'll be I'll just totally take away the temporary cushion, because I'm going to replace it with this. These are your practice problems that you turned in. Okay. So I got a bunch of these. So I'm going to be grading these tonight and tomorrow. And I say grading, really, I'm just looking at them and saying, okay, this is worth 4 points. This is worth 2 points, and just giving you point. You can't lose on it. If you forgot to submit it, you all being virtual, you submit it. And if I will grade yours the next day or two as well. If you forgot to submit it now. You obviously can't lose points. So if you just did one of them, submit it. And you're going to get a point or two. You won't lose if you don't submit it. But this temporary cushion is going away and being replaced by, I mean, wouldn't you rather get a 40 out of 0 than a 22 out of 22? I'm not saying you're going to get a 40. Probably won't be a whole lot of 40s. That's if somebody did a bang up job, and some of you do that. But I mean, you could get up to 40, probably more like in the 30 or 20 to 30 point range. Okay, and this is for second hour. We are in the midst of the beginnings of a tough chess battle in second hour in class. Okay, there was no stargazing today. There was nothing really assigned this weekend because we had a test. The joke Monday was a good one today. All right, so let me show you this. Remember I say David Payne, if you're going to watch weather in Oklahoma and you want to learn something, David Payne is the guy to go to. He puts on these, like as he's doing his forecast, he'll give you some really good, something to sink your teeth into. And he did two cool things. This is the day after the hailstones hit Norman. And he's talking about, sure enough, terminal velocity. And so I quickly took a picture. I paused it, took a picture of the TV screen, and caught him in a bad pose. But so we start off with nothing severe. These little P, kind of you notice them, dime, penny, nickel, no big deal. Not going to mess up your car. Then we get to the severe quarter size. That's an inch in diameter. That was probably the average hail coming down, was at least an inch. And that's when it started to cause a little damage. But then we were getting, I know at my house, we got golf ball and tennis ball. I went out and measured a hailstorm that hit my back porch, and it was in the 2 to 2.5 inch range in diameter. And these things, this tells you, remember in terminal velocity, for terminal velocity, what is that? VT equals a square root of 2, what is it? 2 mg, something like that, over d rho a. I think that's it, as I recall. It's been a while, a few days. But the point is that the m is on top. And so the bigger the mass of the diameter, the bigger the mass of the hailstone, the faster it comes at you. So that's why these things, 70 mile an hour, if you get hit by a 70 mile an hour tennis ball, of course it's on a tennis ball. It's a hard rock-like substance. 80 miles an hour. There were those in Norman that experienced baseball-sized hail. So that's going to actually knock you out. And I've never seen softball. Now, I want to show you, I'm going to change the sharing here. Oh, shoot. Okay, I'm going to stop it. Let me change up the share. And I want to show you this. I don't want that, actually. Hold it. Nah, shoot, my bad. Hold on. Let me get up. I think when you share stuff, it has to already be all called up. Okay, let me show you. Yeah, here it is. This was also on that same broadcast. Oh, I don't have a producer here. It's all me. So I share, there we go. Let me share this with you. I think I can get away with copyright here. I'm not going to have to. It's really bad if you have copyright issues. Can you see this? Can you see, what do you see on your screen?
The video.
You see a hallway, right?
Yeah.
Okay, so this is a condo, I'm guessing, could be apartments, but it's probably a condo in Norman when the storm hit. And these winds were up to 70 miles an hour. Well, there's going to be a Venturi effect. I'll just show you. Now check that out. That is probably close to 80 to 90 mile an hour winds. That is some hail in there, some rain, and there's a breezeway right there. And so what happens when the air gets forced into a tighter tube or a tighter box, it goes faster. And that's called the Venturi effect, which is a subset of Bernoulli's principle, Bernoulli's equation. And so that air was going through there at probably 80 to 90 miles an hour, straight line winds, straight line rain and hail. Look at that. That would have hurt. That would have knocked you out, or it would have knocked you off your feet too. They were smart enough to back off. But the other thing that happens is with this Venturi effect is it sucks you in, because remember, this creates a low pressure zone all around it. So they didn't get too close. If they'd gotten right in here, they might have been sucked into that. This happened, okay, about 10 years ago, we had a tornado at Norman High. And okay, so what we used to always do at Norman High is the kids would go to the hallway, in the science building, and they would all, get on their hands, they get down on their, and they're kind of put their head between their knees kind of thing. Well, we'd practice that. Well, then when this tornado hit, it blew open the north doors of the science building and blew open the south doors. And that right there, see that hallway? That became the hallway at Norman High. Not with all the rain, but all the wind. And papers are blowing everywhere, books, kids, backpacks, and just going down the hall, kid rolling around. People were screaming and crying. It was one heck of an experience. So that's why you're not at Norman High right now, but that's why we now drill. We go to the teacher's lounge, the main teacher's lounge in my room. We don't go to the hallway anymore because of that. What happened on the 28th in Norman, Oklahoma. Okay, so kind of cool. All right, so now on to today's physics. We're behind in here, so I got to move kind of fast. Normally we're like usually one of the lead classes here. Okay, here we go. Let's get out 6-3. We've done number one. I kind of went through that with you. That was the wooden arrow exercise with vectors. Number two, you can get that probably off your practice problems. It's very similar to the practice problems. So I think you can do number two, 2A and B. And that's also similar to what was on the test. But let's look at number three. Let's wrap up 3A and B today. We did 3A, and that's where we ended it. So this is from Thursday's class. So we have a box sitting on a box, if you missed it, a box sitting on a box, and we're showing the forces acting on those boxes. Okay. And then you have to label each force. Now you can't just put M because there's two boxes. So you have to say MA, MB. If there's three boxes, it's MA, MB, MC. On the normal force, you can't just put an N. You have to say, well, what was the source of that normal force? And that's why this is NB and NA. Now, did we mention Newton's third law? We did not. Okay, so this is an example of Newton's third law. So Newton's third law says that if I have two bodies, now that's the thing that people mess up on Newton's third law. If I have two bodies, one affecting the other, the force that body A puts on body B is the same as the force of body B on body A. So rather than have you try and listen to me there, let's just go right to it. So this is going in, this will be on the next equation sheet. So far, one of the things, so far we have 15 equation sheets. And hopefully you've printed those off, or you at least have a PDF file of them. You'll use that in college. This will be on side 16. So here is Newton's third law written three ways. Any of them are appropriate to me. If I say, give me Newton's third law, and you do any of these three things, I'll say, okay. One thing I will not accept is action reaction. If you say action reaction, that's all you say, you're going to get half credit, because that leads to a misconception. People always say, it's Newton's third law, action reaction. No. You have to talk about specifically body A, body B, as Newton did. So the first one does it. The second one shows it in vectors, two forces pushing on each other. You could have two forces pulling on each other, whatever. And then Newton's third law, written in equation form, force of A on B is equal and opposite of the force of B on A. Okay. So that is Newton's third law. And this will be on sometime this week. You'll get the next equation sheet. We'll get up to equation sheet number 20 by, I'm guessing, about 5 more sheets by the end of the year, by May 25th. And then there'd be 10 more sheets, though, that'll come at you in June. June's going to be packed with the good stuff. What normally we might be talking about in May. We'll do that, plus bike rides and, picnic and tour buildings and stuff. We'll do all that in June. Anyway, this is on sheet 16 of the 30 sheets that you'll eventually get. So going back here then, we have what's called Newton's third law. Yeah, I'm recording this. Newton's third law pairs. And so, in other words, if I have a choice. I can make this two bodies. I can make a body A, body B, or I could put a circle around the whole thing and claim it to be one system, which means I put a circle around all of this and claim that to be my system. I could claim, I do it all the time. We say a car is driving down the road. I make the entire car a dot. But we know that a car's got wheels and people inside, and steering wheels and all this, pistons. So you could go through and look at it. You can break up each little piece, the rocker arm, and just do a whole day on just the rocker arm. But it's how you define your system. I could say all my classroom is a system and make my classroom a dot. I could make all of Norman High a dot. See what I'm saying? And say, what's the forces on Norman High School? I could do it for Norman or for the Cleveland County or Oklahoma or United States or the whole world. Make the whole world a dot. And we do that when we talk about Earth, Moon, Earth, Sun systems. So you can keep expanding this out. And here's the deal. When you claim a system, all Newton third law pairs cancel. So you got to show this. You got to show the pairs. Well, a pair, let's find a pair here. This N sub B, what is its twin? It's equal and opposite. So look at this, looking at the other choices. What is the twin for N sub B?
NA.
Right, not MAG as some people think, because that's only one body. So the Newton's third law pair is NA. So now circle those and I'll highlight those. That is considered a Newton's third law pair. Now, Newton said this. I never understood this when I first heard it, my first semester of college. He said that all internal forces cancel. Once you do this, these forces, those Newton third law pair forces become internal, meaning that they're only involved, once I make a system out of those two boxes, that NB and that NA cancel each other. And so Newton said, okay, thinking of systems, every system I have, all internal forces cancel. So if I make this horse and buggy the system, then all internal between the horse and the buggy, those forces cancel. If I look at the world, then all forces in the world cancel. He said, what if I take a big circle and put it around the entire universe? Then every force in the universe cancels. So what he said was every force has a couple. It has, well, I don't want to call it a couple. It has a Newton's third law pair. There's something out there for every force. There is a force in the universe that's going to kill it. Okay. That's a statement Newton made in the Principia, and that predated conservation of energy by 150 years. We finally developed James Joule, those guys, finally in Clausius, finally developed conservation of energy in the 1850s. 150 years out of Newton already said it. Newton already said it. He said every force cancels itself in the universe. It doesn't cancel itself, gets canceled by another object. That is conservation of energy, basically. So now let's try it over here on this one. Now we have 3 boxes. Okay, so I want you, first I'm going to hit pause here in a minute. We'll go off the air, and I want you, or if you're watching at home and you're not part of this group, I want you to try now. Give me the free body on these 3 boxes. I'll give you a hint. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 forces on A, B, and C. We're considering them 3 boxes, not one body, 3 separate boxes. Okay. Let me go ahead. I see I got some chats there, but I can't read chat. Hold on. I pause recording. Okay. So for those watching, I'm about to pause. Try it. You pause yourself, try it, and then we'll start up again. All right, so we're back, and I've been chit-chatting with them, but they have, I think, probably tried it. And every one of these lines here represents 2 newtons, so you don't need a ruler. Let's go through this. All right, so A, you have MAG, and then you have N up. So really, this is like the other one was. So that's N, the source is box B. That's MAG, source is the earth. All right, that's it. And these 2 are congruent. You got to show that. And then we go to B. Now, B has a mass twice. So the MBG is twice as long. This relative lengths are important here. What else we got? We also have, now I don't show this as MAG because the source B doesn't know why A is pushing down on it. So it's just N sub A. Okay, it's a contact force from above. And then we have this one up now is 6 newtons. It's a combination, and that is N sub C, you should have said, because the source of that is box C. That one's also congruent. Okay, anybody got a problem so far? Question, now I have the chat open. So question, problem, call it out. Okay, now let's go to box C. Box C, we have, not 6 newtons. So, okay, so it's going to be all the way down to here, MCG. And then we have, now here's the weird part. We have a normal force from above, but that is a combination of A and B. So we have N sub B, okay? So students always want to put A there, like N sub A plus B, or they put N. No, 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 no. Look, if this were 3 hat boxes, and let's say we went up to the attic after the big hailstorm, and we went up there to check on the roof, and grandma's hat boxes that have been up there for 40 years, we saw them on a table, and we take them and we set them so they're all kind of next to each other. If I did this, if this were hat boxes sitting in the attic for 40 years, box C would be shocked. Why would this shock box C so much? if I took box A and box B and set it beside them.
Because all of that like tension is getting released off of it.
True. But what surprises box C so much?
Wouldn't just the fact that box A was a thing surprise him because he's only feeling the weight of like
that? Okay, I got to give you 2 zoom points because you nailed it. It thinks all this time box C has thought that box B weighed 6 newtons, and it thought it had 1 box on top of it. Turns out it has 2 boxes. It never knew A existed, and it finds out that box B weighs 33% less than what it thought it did. So box C would be aghast at this whole thing. So the point there is that on free body diagrams, I mean, these are dumb old boxes. On free body diagrams, you only show the forces of the object that is attached. You go, well, what about Earth? Okay, well, Earth's different. We're in a gravitational field. So A really is, you don't show A on box C because box C only knows about box B. So it seems like, well, that's wrong because that's not, no, that is the contact from, as far as C is concerned, box B. Okay, and then we have this normal force up, and that's a combination of those two. So all the way up, 1, 2, 3, 4, 12 newtons. My arrow's not so good. That's the normal. I'm going to put sub T from the table, normal from the table. And these two are congruent. Okay, there we go. Now, let's do Newton's third law pairs. So now find the 2 pairs. Circle the 2 pairs in here. We already did this one. We already knew about this guy. We got 1 here. That pairs up with this one. Remember, those Newton's third law pairs cancel each other. So that's going to cancel that. And then give me the other one. What's the other one going to be? Oh, I better hold on here. That's another congruent sign. What's the other one?
Normal force of C and then normal force of B.
There you go. So now let's circle those 2. This is actually fairly important stuff here when it comes to pulley systems. We're about to get into, in June actually, complex pulley systems. And that leads us to complex compound machines. And in those machines, when you're doing mechanical engineering, you're looking to see what are my internal forces. So now I go through here, and let's say I want to make all 3 boxes one system. Okay, I'm going to circle the whole thing, make it one system. Okay, in that case, so this is my system. System. Okay. In that case, I would not include NB in either one, or in C. Those that I circled in pink and yellow would not be included. Because remember, free body diagrams are only internal. All sources must be external. They can't be from inside the system. So yeah, so this is all of these, that comes from the Earth. That's external. That comes from the table. The table's external. That comes from the Earth. That comes from the Earth. So yes, those forces are all good. These are those subtleties of free body diagrams that most high school kids do not get into. But remember, I'm trying to give you the advantage. So when you go off to college, you can be helping out your classmates. That finishes up 6-3. Okay, we're perfect timing here. There's that. Now, look what's next. Gold standard. Many groans today in class. But here's my promise. This is the last one, obviously, the last gold standard of the year. And there's 6 of them here. We're going to work 2 of them together. That gives you 4 for home, not tonight, just 1 for homework, but eventually 4 for homework. You'll have 1 on the take-home test. You'll have maybe 1. You may not even have 1, but you definitely have 1 on the take-home test. So we have 6. We have 7 or 8 of those. You'll have to do 5 or 6 more of these because we'll do 2 of them on our own. The point is, that got confusing even for me, but the point is that there's not that many of these left to give. That's the good news. The bad news, this is the hardest one, the hardest sheet. So your homework is number 1, just number 1. That's it. And for them, I'm giving them 2 to up to 3 stamps. So this may, remember, there's going to be a couple of sheets I have to make you turn in. And I graded most of your sheets already. 6.1, I've already graded those. That should be submitted. It should be already in the grades. But this might be the other one. I don't know. I'm thinking it probably will be. So this will absorb a bunch of those stamp points. So it's going to be really worth it to you to do this one. Don't quote me on that yet, but I'm thinking that's going to be probably the next one. We're going to work in the 9 minutes that we have left. We're going to work number 3 together. We'll kind of send you to the board and all, but I sent them to the board on this, the last 8 or 9 minutes of class. Okay, I want to do this together because it is the toughest one on the front. Number 2 looks kind of like, like the one that was on the practice problems, similar to it. But anyway, so number 3, it's, okay, this rotational kinetic energy, you will not get into till the 2nd semester of AP Physics, if you take AP Physics next year. If you take physics course in college for engineers, you'll get into this about November. Remember, they take they take 2 years of physics and cram it into 1 semester. That's why it's a weeding out course in college. If all you do is this class and you don't go in June and all you do is till May, that'll get you through mid-October, maybe. If you take the class in June, that'll get you almost to November. And then if you take AP Physics, you'll probably test out of it. But if you don't test out, you'll make a pretty easy A. Okay, so, but the thing is, it comes at you really fast. They don't go into near the depth we do. And we haven't gone into much depth this year, but still much more than what a college course would do. So my point is that we're not going to even get into this one, not even in June. This is just beyond our course right now, but it doesn't matter because gold standard, all you need is a good formula and then have awareness. The whole point to gold standard is you're getting awareness of how symbol work, manipulating variables, isolating variables, and then knowing how to work with units. And if you can do that, that gets you through pharmacy school, that gets you through chemistry, that gets you through physics. So this is one of those general skills that any biology, any kind of course that has units. Okay. So rotational energy is 1/2 I omega squared. Now, first off, what the heck is I? And I stands for, we won't finish this problem. We'll just get started on today. But this is not homework. Moment of inertia. It's not inertia. It's a moment of inertia, which is weird. But basically, it's distribution. They should have called it distribution of mass. It's how the mass is distributed throughout anything that's rotating. If I rotate this pin, if I rotate it around, like I'm a conductor or something. If I rotate this pin, it has a certain way the mass is distributed. Now this is easy. The I of this is 1/3 ml squared. If I rotate about the middle, it's 1/12 ml squared. If I rotate about the end, it's 1/3 ml squared. Now I'm getting these formulas from calculus. That's why you wait till the second semester of AP Physics to take this, because it's fairly intense calculus using integration. And by the way, in June, we will study integrals. A little bit in May, we'll spend a half day on it, but we're going to go a whole session on integrals and stuff in May. In June, it's one of those reasons why you need to kind of think about doing it. So this is from integrals, but it's r squared dm, which you integrate over mass. You can't do that. So it's all the substitutions you have to do. The point is that you get all these formulas, like for a ball, it's 1/2 mr for a disc. It's 1/2 mr squared, how it rotates. It's 2/5 mr squared if it's a hollow sphere. All these different, you just eventually memorize a bunch of them. What about a square? What if it's a rectangle? What if it's a piece of wood? What if it's, and so engineers just already have these in their head, and they look it up in tables of how things rotate, how mass is distributed. Okay. It's called moment because it affects the torque. Torque and moment are used in the same equation. And of course, this is rotational, how fast it's rotating. So radians per second. So we gave the example in class, only got 4 minutes left, of me swinging a bat if I'm a baseball player. Two things are going to depend on how much energy I put into that bat. One, how fast I rotate it, and two, where is the mass? How is the mass distributed in that bat? So you have different baseball bats. Some baseball bats, some major league players like them, or high schoolers like those baseball bats that mass is more evenly distributed. Some, like big bangers, the ones that are going to swing for the fences, they like more of the mass towards the outside. That changes the I value. Okay. Saying all that, let's at least set this up. So this is not a baseball bat. This is a motor. So a motor is turning. Let's just make it turn counterclockwise. Okay. It's rotating at a certain RPM, revolutions per minute. It's a large motor. I don't know how many horsepower it is. Let's say it's a, 50 horsepower motor or something. So we have a mass distribution around that motor, and then a number, and it comes down to a number. And then we have its rotational kinetic energy. How much kinetic energy? It's putting out quite a bit, 320,000 newtons dot centimeters. Okay, so really not much you can do with this drawing. You got a KR there, you got an I. You're trying to find omega, right? Yeah, you're trying to find omega in terms of revolutions per minute. So my answer over here, my units are going to be revs per minute. And I come over here and say, all right, so I have, well, they already gave me the formula. That makes it easy. So I have KR, I don't have to go searching for one, is 1/2 I omega squared. I got to solve this for omega. So I got 2 minutes here. What do I got to do? Do a little math here. Multiply both sides by 2, divide by I, square root the whole thing. And so omega then, just save me time, go over here. It's going to be 2 KR. Now I say K sub R as opposed to linear kinetic energy, which we won't get to until June, because there's something called the work kinetic energy theorem. Man, this canvas just killed me. Last year it killed me because we had to quit in March. This year it kills me because we such a mess up back in September. Over I, and then scroot the whole thing. So down here we'll have a 2, we'll have a KR, we'll have a 1 over I, and then I cannot forget to square root everything. Voila. And that is far enough for today. We're almost at 2 o'clock, and we will pick it up there. Don't worry about this one. We'll pick this one up tomorrow. Your homework, though, to keep up with the class, your homework is number 1. Okay. If there's no questions, you guys are free to go. If you have a question, stick around.